Hello viewers, in this film we're going to be cleaning a General Electric AEW06LMG1 6300 BTU air the conditioner from 2009. We are going to completely disassemble this, clean the fan, clean the coils, drill in a drain hole, and reassemble it, and it'll be like new, both in terms of appearance and functionality. This was grotesquely neglected by the previous owner and then thrown out. It is caked with mold and dust. Absolutely filthy. So for starters, there's two screws on the side that will take the front cover off. I've already removed those two screws. With those screws removed, the cover comes right off. And that is what we are greeted with on the inside. A complete cluster of dust and mold and who the heck knows what else. This is not the worst unit I've seen, but it's probably in the top 10. I did test it prior to this video, that's why it's wet. It works perfectly still, so there's no reason to throw it out. But there's definitely a good reason to clean it. Holy mackerel, that is bad. And what always baffles me about this is that it doesn't get like this overnight. It takes years for it to get like this. So somebody has been using it like this for a long time. I don't know. Alright, let's get this taken apart. So the first thing that we're going to do is remove the window kit. There are three screws on the side there that will release the window kit. A long drill bit is very helpful in this case. I don't have my super long ones on me at the moment, but this will suffice. And there's going to be a lot of screws and a decent number of steps to this process, but nothing here is difficult. If you can use a screwdriver, you can do this. Side curtain number 1. Same thing on this side. Try to lose as many screws as possible. Makes everything more difficult. Surprisingly, these are in decent condition still. So next we need to remove the top portion of the window kit. They're not too visible on the camera, but there are a handful of screws inside here. Looks like there's going to be 3 of them. You can't see them, I can't see them either. This bench is too tall. Okay, there's the window kit removed. Get the screws out of there. There's 4 more screws in the top to be removed. And now we'll just kind of go around the sides and remove all the screws that we see. These might be spoiled down here. That doesn't seem like it's connected to anything anymore. Actually, those two screws, we can ignore those. Those are for the condenser coil. We might take those out later while we're cleaning. We don't need to get there just yet. Okay, now the cover should come off. Feels very stuck still. What is it stuck on? Oh, it's definitely should be coming off now. Well, there's some insulation that it's stuck to. It's very important that this insulation goes back because we need to have a good seal so that the static pressure builds up and the air pushes through the coil. Well, it is 100% plugged on the inside as well. Oh man, what the heck? Wow. Yeah, that's pretty bad. Good grief. Well, it's going to run a lot more efficient once we get that all cleaned up. I'm surprised it was working as well as it was like that. It's working off practically no airflow. Unbelievable. I don't know why people allow things to get like this. Okay. So that is where my familiarity with the machine stops. I've never worked on this particular model before. So this will be a learning experience for both of us as we go. And keep in mind that this is a free video on the internet offered to you at no cost. It's just a benefit for you to watch me work and learn how I do it. I don't have all the answers going into it. And if you're going to leave rude comments because I don't have all the answers going into it, then pick a different video to watch and ignore the free help. I don't know what to tell you. The number of rude comments I get for situations like this is unbelievable. This does not look like the simplest design to work with. I'd like to separate all the electronics if possible, because we're going to have to do a full soaking clean down of this. So this looks like this is not held in place by anything other than the case resting on top of it. So just take that off. Oh gosh. Some more oh man, this is filthy. Some more mold in there. The blower is going to move a lot more air once we get all that mold off of it. Yes. There's a screw here. It didn't seem to do much. Looks like there are some little tabs. Push these down and that should let the control panel come forwards and hopefully remove it. This is going to have to be very delicately done, but I think I'm going to enlist the assistance of a flat blade screwdriver on this one here. It's a little bit stubborn. That's not doing much at all. There we go. I always forget to shut that light on. Okay, now we have 2 more screws on the front. I'm hoping to eventually take all this out. At least this looks like it's might be modular. Yeah, there's a plug in there, so we can actually go ahead and take this off now. Get this out of the way. There's still a circuit board in there, but at least half of the electronics will be out. That needs to be cleaned as well, but that's going to get cleaned very differently than the rest of the stuff. See where these 2 screws in the front get us. Nowhere. There's a screw down in here that we'll remove. And there's a screw here. It's still not doing us any good. I have a suspicion that this is a Samsung made unit. I've always found Samsungs are kind of a pain in the neck to get apart. Try this screw. Okay, there's one more screw over here. Okay, we're making some progress now. Might be time to start making some diagrams. Notating where all this goes. This slide out. Yep, that's good. Yeah, we should be able to remove this. We got a transformer here that can stay connected. We've got a tie wrap on there which we'll take off so we can detach all these different components. If we cut it right at the end, we might be able to reuse it. Yes, I am cheap enough to reuse tie wraps. Okay, so now let's see here. This can stay connected to that. Let's detach the capacitor. Now the capacitor if it's still charged up, which it probably is, that can pose the shock hazard. So you want to touch the ends of the capacitor. Capacitor mount. This is a 635 microfarads capacitor, so 6 microfarads on the fan and 35 microfarads on the compressor. And here's our compressor. This is the compressor lead, this is the fan leads. So now this is where we're going to get a piece of paper and write down where this stuff goes, which is important because these colors are not universal across any of these machines. So for the compressor, we have the blue, which is common. That was cool. Unfortunately, I don't think that got caught on a video, but blue is common. And yellow is run. And red goes to the relay. And I'm just going to contact with the screwdriver the common to the other sides to discharge the capacitor. Got everything written down here. Okay. And now for the fan. So the compressor is recorded. The fan, we have red side which goes to run. The orange becomes the common. We have the blue from the controls is common. Okay, so now we have enough data. We can take the capacitor off and not be confused when putting it back together. We're going to take a break from the documentation and check the capacitor's values to make sure that it's still good. So we'll use a technician's multimeter to perform the test. Capacitors are consumable. I'd say 25 to 30 years is a reasonable lifetime. This is getting towards the end. So we'll check the compressor. Okay, check the compressor side first. Well, if you put the meter to the right settings, it'll work a little better. 35.3, that's pretty good. Check the fan, and that is 6.02. So this capacitor is checking out good. So we're going to reinstall that capacitor. Not going to replace parts that aren't broken. Okay, back to the controls and the documentation. Just 3 fan speeds left. Top to bottom, it's blue, yellow, black. Worst case scenario, the fan speeds are in the wrong order. we write them down and put them back the correct way, they'll be fine. Okay, just in case I lose the piece of paper, take a picture of it for my own reference, and maybe yours if you've taken the wires off without writing it down, which people do that. I don't know why, but it definitely happens. And now we'll remove this here. This is a little bit dodgy to get these off. I do like that this is modular like this, but it is not easy to get these terminals off of here. I don't like to use pliers on flag terminals, but we don't have an option here. Okay, grounding screw up here, take that out. And I'm actually going to put this back in just so that I remember that's where it goes. Okay, so now our electronics are isolated. Here's your transformer that burns up a couple watts all the time, even when it's off, which is one of many reasons why mechanical controls are superior to electronics controls. This cord is even dirty. We gotta clean the cord up too. A joke. Why people don't take care of their equipment. We'll just throw it out and buy a new one. No, that's wrong thinking. Okay, so that's all out of the way. We got a couple more screws here. What the heck purpose that plastic thing serves, but we'll put that back too. Oh boy. Oh man, we've got screws on the inside here, and the heads are just gone from those screws. Well, I have to say, as much as the performance of this machine is respectable, the design is crap. This is a horrible, horrible design. I mean, I've taken apart probably hundreds of air conditioners over the years, and the GEs from this era consistently are a pain in the neck. So it looks like to get the bulkhead off, we now have to direct our attention to these completely rotted out bolts here, which we're likely going to have to just drill out and replace. Because I don't think that there's any way we're going to turn this. Well, actually there's more of it left than I thought. We can get that to clean up a little bit more. Yeah, there's really not much left to that screw head, but let's see what we can do. Can I get, see if I can clean it out a little bit more. You know what? There actually is a fair bit left of that head. I think we're going to get that to come out. Now how we're going to turn this one underneath the fan motor. Is there one in there? No, I guess not. I gotta go get my longer bits. Indispensable. Huh. I can't believe that actually just came out like that. Unreal. There's another one over here to the left of the fan, which is going to be very difficult to reach. It too looks like it's in pretty good shape though. I think I'll be able to get it. Yeah, I got it. Unbelievable. I can't believe that actually came out. Both of those came out just fine. This is some good screws to not rust in these conditions. Alright. The bulkhead is almost out. I think that there's got to be one more screw that we're missing. Yeah, there's one right here. That too came out just fine. I don't know how, but it did. The bulkhead and the fan are now free. So next we have to remove the condenser fan shroud. That will let us take the fan out completely. Okay, I think at this point our fan will lift out. Not quite. Not quite. You're kidding. That is part of that? Can't be. No. still not coming out. There are more screws there. It just rusted shut. I think it's rusted shut. No, there is. There's one more pesky screw. Unfortunately, this screw, unlike the others, the head is gone. So, since it's so rusted out in this particular area, I think I can just hammer the stud off with the screwdriver. That's the screw right there at the center of the screen. I'm gonna see if we can just chisel that away. Okay. So I just broke off the tab that was stuck there, that completely rotted out screw. And now I think it'll come off 50 years later. Now this is stuck. Okay. This definitely has my vote for worst physical design I've ever worked on. The compressor is a Life's Garbage, or the LG compressor. So now we can get a better look at what's going on here. LG was still a reasonable brand at this time, but nowadays I don't have any use for their stuff. So there's a slight area in the middle there where air can get through the coil, and that's it. It is otherwise completely plugged. So the fact that this was running and not even going over the rated current draw, it's incredible. I guess you can kind of still see through the coils, but they're not doing much. I'd like to remove this stupid piece. I think there's one more dang screw. I don't think that that's one with the refrigeration lines. Tell me there's another screw or something in there. I don't understand what it's caught on at this point. I mean, we can deal with it if we have to like that, but I just, in concept, I don't understand what it's caught on. I have no idea. It doesn't feel like it's caught on anything. It's moving. It's 100% free. So why doesn't it come out? There's got to be a secret handshake to get this to come out. I will not be able to sleep tonight until I get this out of here. What on earth is keeping this in here? I tell it's going to be a joy to get back in place. Ugh. Okay, now, however many minutes that took, it is fully disassembled. We have a cleaning nightmare ahead of us, and then a reassembly nightmare. Now this is what the coil is supposed to look like. And this is what it looks like now. Oh man, what a mess. What a stinking mess. It's day 2 now. We're going to vacuum this out first just so that all these large contaminants don't end up all over the yard. And actually some of these pieces are not even going to fit in the vacuum. And then we're going to just douse the whole thing in condenser cleaner. I use condenser cleaner very sparingly because it can do a lot of damage if you use too much of it. But in this case, this is so bad, we're not going to be able to get it to come clean with anything else. This stuff is very hard. I'm not really sure what that is. Alright, that's all the vacuuming that we're going to do. It looked like it was a lot more when it was in the machine. Okay, now that that's out of the way, I'm going to get this thing outside where it is a beautiful 87 degrees today. very nice out. Unfortunately, this is the second to last day, so I don't even think we're going to get to use the machine by the time we get it back together, but that's a different story. So we'll get this thing outside, we'll make up some condenser cleaner, and we'll get this all cleaned up. Before we start the cleaning, I also want to take this apart so we can clean this stuff all at once. Super brittle, this blade. This is going to be a challenge to get this on and off safely. I gotta put this fan on, it's getting hot in here. Okay, so the nut's going to come off relatively easily, which is not what I was expecting. And the blade is actually not totally locked on there either. I think what's holding it back is there's some old thread lock around here. Let's see if we can get that off. Nope. This is usually a little more forgiving because it's on the inside. It's disgusting, but it's off. Now we got to keep fighting with that condenser fan. So this shaft does have a flat spot, so what we can do to hold it in place is we can take a wrench and put the wrench on there. I'm not worried about if it gets a little scuffed up because we're not going to be taking a motor apart. Ball bearing, it doesn't need any service right now. And now I will use the wrench to hold it in place to kind of turn this a little bit more. It is turning on the shaft, it's just not coming off. There it goes. Washer, very rusty. Okay, now we can clean this, which is also very rusty. Clean that delicately. There's all that's left of the bulkhead, and here's this nasty styrofoam thing we got to clean up. Now, it's not the quietest running bearings, but they're quiet enough that we're going to leave them for now. As you can see, they're still spinning freely. If it does start to get noisy, then we'll just replace the bearings. But for now, they're still working just fine. I don't think we need to mess with it. Not the greatest lighting situation under here. I have a little halogen light up there, hopefully to make it a little better. But yeah, I'll have to work on that. So let's get the cleaner mixed up here. Probably gonna go about 1 to 5 on this. Need a pretty strong mixture. I just discovered a massive freak show inside the house. With the stupid sewage pump downstairs, so that'll be the next gross cleaning project after this one. Now, let me make sure I mix this up very good. I've noticed that in the past, the cleaning effectiveness of this has been inconsistent. And a lot of people suggest it's because I wasn't mixing it well, and I agree with that. So I've mixed it better. And now let's see what happens. This is the first time I've ever had this cleaner not work. This is ridiculous. I shouldn't say it's not working. It is working, but it's not working enough. Wow. Well, the evaporator came out pretty good. You cannot say the same about the condenser. There is a corrosion resistive coating on the evaporator side of this coil, and that seems to have worked pretty good. Despite this being totally caked, it's cleaning up pretty good in terms of its integrity. There's not a lot of coil rot at all on here. I'm going to have to make some more cleaner, and I'm going to mix it stronger this time because that was not good enough. So this is probably more like 4-to-1 now, as opposed to 5-to-1. Yeah, I can't believe how integral that coil is still, despite all that rot. I mean, despite all that dirt sitting on there. There's all sorts of crud stuck over here still. I'm not even sure what that is. You don't want condenser cleaner on the umbrella. There will be nothing left of the umbrella. Oh man, it's still not getting it off. I really don't like to clean coils with any kind of friction, but I'm going to have to brush this because it's not coming off. And this stinking Lasco 3733 is shaking so much it's causing the air conditioner to shake. No, this is starting to mess up the coil. We can't do this. That's exactly why I don't like to brush coils. Well, we'll just keep going with the water, and at some point it's just as good as it's going to get. There's a little bit of rot on the surface, but it's not too bad. Now, that's like 90% better. I'd like to get the rest of this hair off of here so that the rot doesn't continue, but we're getting to that point now where we're starting to use too much coil cleaner, and that's going to cause its own host of problems. This staining up here, I'm not worried about. That's the dust. We'll just hit these areas where the dust is one more time, and that's going to be it for the coil cleaning. The evaporator cleaned up like brand new. That's amazing. But the condenser definitely leaves something to be desired, though. Get some of that mold off of here. Most of the mold came off pretty easily. I don't know if the video is picking up on it, but that coil cleaner is turning like a silver color. That's when you know it's way too much. Because that silver is the coil. That's not the dirt anymore. Unfortunately, I can't get that off within reason, so it's just going to stay. But it's not super relevant anymore because there's not going to be moisture kicking around in there, so won't be any moisture for it to hold. Much clearer now than it was. It'll work a lot better. disappointed by the way that looks, but it is what it is. There's a careful balance, and we've reached it. So we're not going to go any further with the coil cleaning. Now we have to do a tremendous amount of rinsing. Very important to get all traces of this cleaner out of the machine. That's why I always show this lengthy rinsing process, even though it's kind of boring. It's extremely important. It's mostly important for the evaporator to be 100% perfect, because that's a health and safety hazard when that's not properly cleaned. Okay, that completes the coil cleaning portion. I'm going to go set this in the sun now to dry. We got to drill a drain hole too. I'll do that later. More moldy components. This time we have a moldy evaporator fan, a moldy evaporator chamber. Ugh. Mold. Well, that's going to need a second coating. Yeah, it came out pretty good. and dusk.
Kind of sticky residue in there. Maybe that's from where it was dumped in the trash. It's scratched, I guess. I don't know. Oh, this isn't busted. It just came out of place. It works perfectly.
Technically the motor should be waterproof from top down. Yeah, do we want to go spraying the motor with water? Probably not, so we're kind of proceeding with caution in that area. We're going to reassemble now. Before we do that, I want to just take a closer look at this coil to try to explain what's going on here. Turn these fans off so it's not so loud. Put this other quieter fan on. So what I thought was dirt that was not coming off, I think is actually corrosion. So all these spots here where this dirt is present, or what I thought was dirt, I can kind of get it to come off with the coil comb, but it takes the fin off with it. And so this is where, see how it just broke like that? So this is where the question becomes, do we keep going and try to make it look perfect, or we leave it as it is because it's 90% better than it was, and you know, be done with it? I think that the latter of the options is the better. As you can see, it's clear through the majority of the coil now. I would say it's at least 90% open, if not more. And reality be it, it's going to work much, much better than it was before. Although somehow before it was still operating in spec, which I don't understand, but the condenser, or the evaporator, cleaned up very nicely. Very clean. And the condenser is okay. It's good enough. Certainly a massive improvement, that's for sure, compared to the way it was before. All things considered, I would actually say this coil fared very well. When you have that much dust on there, both in the front and the back, and then you have the water splashing from the stupid slinger nonsense, it holds the moisture on the coil, and then it will start to corrode like we saw here. So it's just, you know, reason number 4782 why there should not be water sloshing around inside a metal air conditioner. Next, we're going to check the compressor terminals to make sure that they're in good condition. There's really no unlikely we're going to do anything here. This is just a visual inspection. Make sure there's no moisture or anything else in there that shouldn't be in there. Things like that. There is some moisture, so we'll dry that out, but everything else looks fine otherwise. And there's the terminal block. Had a good rubber seal on the bottom, so it's kept all sorts of stuff out over the years. But some water has made its way in by the overload here, so we'll clean that off. Make sure everything's dry before we seal it back up. This is kind of a delicate area because this is all under pressure, especially during operation. Rotary compressors are housing high side, so this can be couple hundred psi in here on these terminals. Definitely want to make sure that these stay in good shape and no rust or anything forms. All the connections look good, no corrosion that I can see, no oxidation. Everything looks 100% under here. So I'm not going to mess with anything, we're just going to put it right back. Like the rest of the machine, horrible design in terms of serviceability, and it's like No, it could just go like that. This is not necessary, but we put this over here to make it more difficult to get the terminal cover on and off. Somebody in the comments box, I've read this comment since I started the video. Somebody in the comments box suggested that this is made by Gree, which is a brand famous for junk HVAC stuff, particularly recalled dehumidifiers. They made millions of recalled dehumidifiers through the 2000s. While this machine seems to work pretty good, the design of this is atrocious from a variety of aspects. This is probably one of the most difficult air conditioners to work on I've ever dealt with. And there's just no reason for this to be this complicated in terms of disassembly. It should be simple. We don't have to get this too tight. There won't be water in here anymore, so it's not really a problem. Also just want to keep bugs and junk out. Bugs and dust. Okay. Now we've got to put a drain hole. We're going to use a step bit for this process, which is like a cone-shaped drill bit. It is by far the best tool I have used for drilling through metal. This particular one is from the Milwaukee. It is the Milwaukee 48988920. Whatever, just read the model number yourself. My dyslexic brain is not going to get it right. It's a number 4 jam-free step drill bit, and it's great. So we're going to have to drill multiple holes here because we're going to be combating both moisture from condensation and moisture from the rain, because the case in this has that stupid design where there's a vent on top, so every time it rains it's going to fill up with water, which is dumb, very dumb and stupid. So the main drain for the condensation will go right here. So the water comes out here. We're going to put the hole there so that it won't have a chance to go back to where the condenser is. Nice and big drain so it doesn't clog up easily. Clean the burrs off. Very few burrs. This gives you a really nice clean hole. So now we also want to put a drain at the lowest point of the machine to deal with any water that comes in from the rain. And in that case, we're going to want to put it under the condenser somewhere. So we're just going to very delicately lift this out of the way, and while we're under there we'll do a little bit of cleanup. You can see the rust starting to form under here from the water sitting. I'm going to drill in right here, put a hole here. Okay, and that should take care of any rainwater that gets in. One other thing I'll do, I'm going to take a screwdriver and just kind of flex this down a bit so the water will kind of tend to go in there. I'm going to do the same thing here as well. Is that the water will have a tendency to kind of go towards the middle and out as opposed to down and around. This should work very well, this drain. Okay, now we'll vacuum out the shavings and then we'll deal with the reassembly, which is going to be a serious challenge, I think. You can see this portion of the coil has the same corrosion resistive coating that the evaporator does, and it worked. You know, this is the worst part of it in terms of dirt and moisture exposure, and it's in the best condition, so why they didn't coat the whole thing is stupid. Okay, and as long as you don't hear s at some point, we're good. Alright, so we've got holes. Get that out of there. Clean up underneath the table here as well so we don't get any nasty surprises when I'm trying to put this in the window. Okay, all cleaned up. So I think we're going to start with putting the bulkhead back in. Try to give you the best view that I can. I guess we'll have to we gotta put the fan blades on and some of the styrofoam pieces back first. I'll go ahead and bring those inside. So this is the interior side.
The bearings could definitely fare to be replaced. And I kind of wonder if we should just replace them at this point. We're halfway there, most of the way there, rather. I mean, they're not going to get any quieter, that's for sure. But then again, that amount of noise is going to be drowned out by the machine anyways. Should we replace them or not? It's a tough call because we're so close, but at the same time, these bearings could last another 10 years, and then it's like, why spend the money? I think we're gonna reassemble it. This did not come quite as clean as I was hoping it would, but these never really do. It still looks discolored and gross, but the way I look at it is whatever didn't come off with that cleaner is not coming off into the air. So, although it doesn't look great, I don't think that it's going to smell or create any kind of health hazards. The blower cleaned up pretty good. So we put one washer first. And there's a flat spot on both the shaft and the inside of this that lines up. I must not be getting that right because it's not going on there. There we go. That might be the nut for the outside portion. It definitely was. I don't think that we're going to be able to really hear the bearings. We'll see. If it becomes a problem, we'll just take it apart again. It's not like we're never going to have to take it apart anyways. Condenser fan, this is super, super brittle plastic. From the heat, the moisture, the sun, horrible conditions for something plastic to be residing in. This one is reverse threaded, which is very confusing. Okay. So I think that's all. No, this has to go on there. Does this have to go on before the blade? No, it probably normally does, but since it's now split in half because of the rust, I might be able to just slip it over there. In a perfect world, that should go on first before the blade. Okay, I think that's everything. We'll take a quick look outside. Make sure we got all the pieces that go on first. Yeah, I think so. Let's drop this in place. This can be tricky when it's one person because you got a lot of moving parts to line up. Man, this is making a mess here. Whoa. I'm expecting this to be a complete and total reassembly nightmare based off of how many screws and things there were taking it apart. I just have to go through it very meticulously and line everything up slowly and get it back to where it needs to be. One crazy piece at a time. Alright, that looks pretty good like that. Fan's not spinning, but that's okay. We know that it's not aligned properly. So I'm looking now for the screws in the bottom where the bulkhead was, and we're going to use those screws as our gauge for where this is supposed to be, those screw holes. Okay, let's see one right there. Okay, so that's about where it's got to be on that side, but this is totally way too far up on this side. Here's one of the screw holes there, so we'll try to line that up. There's one over there on the other side. Try to get those lined up. I think that's going to be the best way to start. That's where that needs to be. I'm not going to necessarily screw it down yet, but I'm going to just put the screws here to kind of hold it in place. Just one or two turns in. So we know that later this has to eventually move up like that, but that's fine, doesn't have to do that yet. Okay, so pull that forward, and now that's lined up down in there. Okay, so we'll drop the screws into there, hold in place on this side. And look how many screws there are. This is just crazy. Way more screws than is necessary. I don't think I've ever seen an air conditioner with this many screws before. And there is a third hole behind the fan here. I'm going to put this screw, since this is the worst of the screws, I'm going to put this one over here where it's easiest to reach. This way, if there does become a problem in future years, it'll be the easiest to reach to deal with it. this screw is pretty good still, so I'll put this screw back here where it's kind of hard to reach. Okay, and we'll put this flaky screw over here where it's easy to reach. It's amazing that none of those screws have rotted out yet. Okay, so now we need the part that goes there. That was a nuisance to get out. That might be the worst part of the reassembly process. Where the heck are all these drips coming from on the carpet? Oh, I see what that is. That's not good. And that's not something I've ever had happen before. The pipe is condensating, the outdoor water pipe, because it's so hot out today. The first day things get hot and humid. Today it's 89 over 64. That's pretty high. All sorts of weird things start happening in terms of the building. Stuff breaks, stuff malfunctions. There's something flaky going on downstairs too, which I gotta deal with. Alright, so I think that this went like that. And this ends up here, and this ends up in here. Now getting it there I think is much easier said than done. This was very problematic when I was removing it, and I expect nothing but a headache trying to get it back. Try to slide this screwdriver under here to protect the insulation on there from getting sliced as this goes in, but it's not working. Alright, that's close to where that needs to be, but it's not sitting correctly. It needs to come over more and then eventually, I think, actually drop into this slot there. And on this side, it looks like it has to go in between. Oh, it's hard to say. It looks like that stays like that, but then this has to go, I think, on the other side of this. Or does it? Yeah, it does. It's got to go on the inside of that. Like that. And then it ultimately goes, I think it goes in back of the evaporator tray. I think it's kind of in place over here, but it's definitely not in place over here. Okay, so now the problem is over here. This needs to move back so that it can go. That's like a full stop. Why is it not going back? There it goes. Okay, I think that's pretty much in place like that. And then this is going to go behind there like that. So these tabs are in front of the condenser rows, and that piece is ultimately behind here, and this and that all line up, and then these two screw holes line up. There's a screw hole in the top that lines up, so I think that's good on that side. And on this side, it's not quite where it needs to be on this side. I think part of what's going on is the rust is getting stuck on some of the styrofoam as it goes down. That's just about lined up there. I can screw that in now. Those are lined up. That's lined up. Okay, I think that we're actually all lined up here in the front. I'm going to lock down the screws for the bulkhead. Keep that from moving around. And we're going to use a low torque value. Maybe 8 or 10 is good. I don't want to go crazy. There's no reason to put it that tight. The fan is not spinning freely at this point. I think that's because why is that? It's hitting the bottom of the condenser. Why is that the case? Because the fan should be free now because it's in place. There we go. Okay, the condenser's got to be pulled forward on the other side. It's now hitting the shroud, but we'll fix that. Okay, now it's free. Put some of the screws in over here. I don't have any recollection of which screws go where. They're pretty much all the same size. I don't think that it really matters. Gonna go down to 6. 8's a little bit too much. That's good. Now some of these screw holes we got to compare to the case because some of these will be used after we put the case on. I think a lot of these screw holes are used with the control panel, so I'm not going to put those yet. Fans spinning freely, both fans, not hitting anything. Alright. Now the condenser is floating at this point because the screws that hold it in place are gone, so oh well, nothing we can do about that. They've rusted away. Alright, so we've got the case left. I'll just be able to compare the screw holes. Now I've got that strip to put on top to funnel the air into the condenser. Very important. If this is not there, you'll get a loss of static pressure. So make sure that this goes back. There's going to be a lot of loss of static pressure because now there's holes around here. We could put some steel wool in there actually to block that up. Put some steel wool in there and put some on the other side to close those gaps. And I'm going to get that piece for mounting the control panel and the top styrofoam. Well, we're not done yet, but so far this is going a lot easier than I anticipated. Okay, so these two pieces are held by the case, so no screws go there. On the side here, it looks like one of those screws is held in by the case, and it's going to be the one in the front. So the one in the back, we can put a screw. And if you're really particular about stuff like this, you can also put some insulation around here. I'm not that particular about it. This is not an area where there's indoor air passing through, so I don't really care about it. Could a bug potentially come in through there? Yes. Could 2% humidity come in through there? Yes. This to me is a game of improvement, not a game of perfection. But that's a pretty big hole there. I think we should probably do something about that. That's going to let a lot of air out. Spray foam also could be used in a case like this, but we're going to use the steel wool. Okay, I'll put a little bit on the other side too, just to get as much air through that coil as possible. But clearly, as the machine has already demonstrated, it'll work fine with much less airflow than it's supposed to have. But we'll give it the best shot it can have at working properly. Okay. So now let's see what screws need to go in on this side. So it looks like this screw can go in now. These three screws can go in now. Or can they? No, those screws are for the case. That's like that. That top screw and the bottom screw go in now.
this one and that one. That is stripped out. Any bigger screws? This one looks a little bit bigger. Nope. They're all stripped out. Oh well. Okay, I think that that's everything except for the control panel stuff. So here's the control box. And that goes in there like that. Or does it go like, no, is that correct? Yeah, that's the way that went. And then there's this weird plastic thing that went on there for some reason. No idea what purpose this serves. Oh, I no longer remember where this went. Might have to go back and look at the video to figure out where this went. I don't see anywhere that these holes can actually line up. That doesn't make any sense. What the heck? There's literally no way for that to line up. What on earth? I really thought that this was down here at the bottom somewhere like this. Does it just go like that and the other hole is bogus? I find that hard to believe. I'm gonna have to look back on the video. Well, I just looked back on the video and sure enough, that's exactly how it goes, just like that. Where's telephone? I just checked on the video and sure enough, that's the way it goes. It just sits there with only one screw connected. So, fine. That's how we'll put it back. Makes it a little bit cleaner. Where is the rest of the... Here it is. Here's the rest of the controls. Definitely need to clean the thermostat. Because that handles the interior air, so that needs to be clean. Get a little bit of water on there so that it actually cleans. It started raining, so I had all the pieces out in the yard to dry, and then they were dry, and now they're all wet again. Okay, that was not as controlled as I wanted it to be. Well, that's unfortunate. I was going to do some other things outside today, but I guess that cancels out those plans. It cleans up a lot better with some water. It's getting even more humid out now. It's up to
81% humidity now with the rain. Okay. I don't know why that's wrapped in foam, but it is. I guess the first thing we should do is reconnect the grounding wire, because we're going to lose easy access to that momentarily. I think that was like that right there, and then this goes like that, and then the plastic control part mounts to the front. Where does the thermostat run through? Does it really just go like that? It might. Okay, we need the diagram, we need a capacitor. There's the capacitor. It's a little dusty. I'll go ahead and wipe that down. Not going to replace it because it's still working fine. It checks out fine, so we're going to give it another season. Maybe when I replace the fan bearings we can replace the capacitor, but for now it's fine. No reason to swap something out that's working. Okay, so according to our diagram here, from the compressor, which is going to be this, the blue is common, so that's our large terminal on here. Oh, a piece of dust just went up the stinking paper. That's pretty cool. And the yellow is the run, so that goes to the hermetic side. And then this goes to the control board. From the fan, red is the run. And orange is common. These are the fan speeds. And then blue is also the common. Okay, so then we go to the control board here, and let's just mount the capacitor at this point. We've got the wires on there. Go ahead and secure this down. The pollen today is bad. My neighbor just mowed the lawn and the pollen is kicking up everywhere. Okay, capacitor's in place. wires is connected properly. Now we'll secure this transformer down, which supplies power for the electronics controls. Where's the output on this? Oh. Gives some kind of low voltage for the controls to operate. And this transformer runs 24/7 whenever this is plugged in, which is part of the reason that, or no, this is the exclusive reason why the electronic controlled units draw power all the time, is because you're always powering a transformer, which is powering electronics, looking for your input, as opposed to a mechanical dial that doesn't require that. One of many reasons why I think mechanical controls are superior to digitan controls. Okay, on the control board, the red goes to the compressor relay, and the fan speeds are blue, yellow, black. Yellow, black, I don't remember now which direction were these facing. Are they facing that direction? I guess it doesn't really make a difference. I think that they were facing the other direction. Yeah, they were definitely facing the other direction. Okay. So this screw over here went in too soon because this is supposed to grab the control panel corner. And now the screw is in the floor. The worst place for a screw to be. It's almost as if this was designed not to be serviced. Okay, so that should be the controls all back in place. The only thing left to do is plug in the front piece here, which I actually still want to wash this. So I'm going to take this apart real quick with a properly sized screwdriver tip. I'll just go wash this inside the house because now it's raining outside. Oh, gross. So there's our switches. If need be, we can spray some deoxit in there to make those work better. But I think it should be okay. So I'll go ahead and wash this off now. Control panel has been cleaned. Unfortunately, it was like glued on crooked. That's just this front label that's crooked. It wasn't like the actual panel itself. So I can't really correct that. I could potentially peel it off and put it back on. I don't think it's worth that. So that's just going to be crooked. I guess the thermostat goes out through the air. That makes good sense. So let's reinstall the board into the unit here. I am so curious to see how much less power this is going to draw now compared to last night when it was completely plugged. This is a little plug that this goes into on the back here. Okay, that is in place. So all the wires are out like that. This is going to route over there. And there's little tabs on here and here that are gonna sit in those squares. Make sure that's up like that. And then those tabs in the top, push down and in. That's routed properly. That's all routing properly. I don't know why this whole apparatus here is so big, but this goes like this. And this you want to make sure is not too close to the coil. If this is too close to the coil, it'll sense a cooler temperature than it actually is, the air is, and it'll what's called short cycle, which is not helpful. Can't get much cheaper than that, stinking styrofoam air chambers. At least this part's metal. Okay, I think that's pretty much it. We'll do a quick power on test to make sure it's working before we put the cover back on and all of its million of screws. Everything's running. Just make sure we get a little bit of gas sound before we shut it off. Oh yeah, I'll put a tie wrap around these those cap tubes so they stop vibrating, or a wire tie or something. Maybe I can reuse this one. This one will work fine. Oh yeah, they're getting cold. It is working. Probably working better than it has in years. Yep, it's getting cold. Okay, we're good. Just check the high speed too. I don't really hear the bearings much. I think that was the correct call to leave them alone until further notice. Okay, put the top cover on, and then this is completed. We lost that piece on top of the condenser that blew off. Where did it go? You need that piece. Here it is. Make sure that it's good on the other side too before we close it up. This rust down there is making me kind of nervous, because if this ever collides with the fan during operation, that blade is going to end up shattering, I think. Seems like for some reason it's inclined to hit it now. It wasn't hitting it before, so why that has changed.
Okay, now it's a reasonable distance away.
Okay, and that'll get held in place by the top case. I'm going to start with the screws in the top because there's no way we're going to get those in place if we can't move the case around. Okay, now that those are in place, we will attach the case to the bottom. Okay, the fan is still spinning freely. Oh, it's really pouring now. Alright, now we'll put the window kit back on. This was dry. I had it sitting out in the sun and it started pouring rain again. So now it's wet. But that's fine, it'll dry. It's not going to throw any codes or whatever other things people say about it. It's not accurate. That screw is not long enough. One of these is not like the others. And since there's so stinking many of them, I'm not sure which one that is. I might just go grab I'll just go grab a new one. We got plenty of screws here. This will work. Is that grabbing or not? No, I need something with a actually even bigger thread than that. No problem, I should have something. Oh, that's a weird head. I think we're going to have to just get that weird bit out because that is the size that I want to put in. And they're all like that. So this is a hex. Huh, even that size is still not working. Well, reality be it, the 2 is enough. That was probably busted prior to it coming into the shop here. Okay, so now we have side curtains to go back on. This one goes to the left. That is working properly. These are very short screws, they don't turn very much. Okay, and lastly, we will reinstall the front cover and the filter, which is pretty much worthless, as we saw. I can probably clean that up with melamine foam. That's scratching. Keeping in mind this was thrown out, this was found thrown out, so it wasn't exactly removed from its previous location with care. Okay. It is now back together. That was not as daunting as I expected it to be. I would say it's probably better to slide it in from the left side so it doesn't get caught on the thermostat probe. All right. Let's shut this on and see how it works. Very curious about the power consumption here to see how much it went down. It's 77 degrees, so it's only a 1 degree difference from when we tested it last time, so very similar load conditions. Wow, it certainly pushes a lot more air now. Yeah, considering how humid it's getting, I might actually throw this in the window tonight. Those louvers are very ineffective. That's disappointing. Oh well, here we go. Oh, rats. I forgot one more thing. We can do this while it builds head pressure. I wanted to clean up a couple of pieces of the coil here. It's not bad, but just for the sake of being thorough, let's correct this as well. Definitely a good increase in airflow out the back here and the front. This is a high efficiency coil. These are a pain in the neck to straighten out. Some of these pieces are bent beyond what this tool can repair. It'll require manual intervention with a spackling knife or something like that. But we'll correct what we can with this. This has very good flow now, even top to bottom, even flow. Very good. That's not perfect, but it's, again, it's 90+% open. It's good enough. All right, let's see what the power is at now. 494 the watts. I think that's a fair bit less than it was before. Well, I really don't remember. It's allowed up to 590 watts, so it's running a fair bit below its allowed specification, which is good. And it's getting nice and cold. I don't know how it was doing this, but it was working fine before, so it's not like we're going to have a huge difference here, but it should work a little bit better now.
Yeah, much more airflow now. This is definitely recirculating a little bit because you see that went down a fair bit and the temperature in the room has not changed. Oh, the camera is almost out of charge. We're going to have to wrap this up here. Oh, it's working properly. Should work a lot better than it was before. I can feel much more air coming out than I did before. Now it's moving the amount of air it's supposed to move. It's as cold as I would expect it to be. Putting out 58 and dropping with 70, 77 going in, so there's your delta 20. That's reasonable. Now that was a very, very messy project, but it came out great. And this will likely provide decades of reliable cooling to come.